Hi, this is Mr. Lloyd here, and I'm going to go through another exam paper. So this one is the old Edexcel, so the 2011 specification paper, the 2017 paper. So this is the last paper from the 2011 specification for Unit 1 Chemistry. Okay, so at the time of recording, this is relevant if you want to retake your paper from June 2017. And after that, it's the new specification, the 9:1 one. So this is the old specification that started in 2011, and the last relevant exam for this is January 2018. Okay, so I'm going to go through the questions on the paper. And then if you want, you can follow me through the paper and answer the questions yourself by pausing the video and then answering the questions. And then I will read through the mark scheme, so I'll tell you what the answers are. And then I will go through the examiner's notes, so people will know what successful candidates did and less successful candidates did. So I'm actually going to start with the examiner notes, because they have a few general notes on what successful and not successful candidates did. So, successful candidates read the questions carefully and answered the questions as they were set. They understood and used the correct scientific terminology from the specification. They could write balanced equations. They could explain both advantages and disadvantages of using hydrogen as a fuel compared to petrol. Less successful candidates could not recall the results of bromine water tests used to distinguish between alkanes and alkenes. They could not explain the method of extraction used for a specific metal. They could not write the word equation for the complete combustion of methane. They had difficulty in answering extended writing tasks, confusing the disadvantages of using hydrogen with those of biofuels. In future, candidates need to ensure that they revise the factual content of the specification carefully and practice balancing equations, especially those required by the specification. All candidates would benefit from working through past examination questions to practice the skills needed in answering the range of different types of extended writing. The report provides exemplification of a candidate's work, together with tips and comments, or a selection of the responses to the questions. So let's go to the questions. So we start with question 1. Carbon dioxide dissolves in the water in the Earth's oceans. Describe how these oceans were originally formed. Question 1A, that is 2 marks. So if you want to do that now, pause it, and then we'll get back, and then press play when you're finished. Right, so question 1A, the mark scheme. Here is the mark scheme. So a description to include any two of water vapor or steam gets you 1 mark. So mentioning those words gets you 1 mark. Saying that the earth cooled gets you another mark. And saying that the water vapor or steam condensed or changed to a liquid gets you another mark. So if you wrote the water vapor or steam condensed, that's 2 marks out of 2. Okay, so the examiner said the majority of candidates scored 2 marks available, with many giving all 3 marking points in their answers. Common errors and misconceptions seen by the examiners included, in a few cases, the candidates only mentioned water vapor, so achieving a score of 1 mark only. Commonly seen misconceptions seen in some responses were that carbon dioxide condensed or dissolved to make the oceans, or that the oceans were formed of hydrogen and oxygen combining. Okay, so there you go. So that's something to think about. Right, question 1B is worth 2 marks. Some rocks are formed from dissolved carbon dioxide. Describe how this happens. Off you go. Right, the mark scheme for 1B is a description to include any two of, so you can get a mark if you wrote, marine organisms or sea creatures absorb or take in carbon dioxide. Another mark for saying They use carbon dioxide to form shells or calcium carbonate. And you get another mark if you wrote, the shells form sedimentary rocks. So sedimentary is in bold, which means if you mention the rocks are formed, you have to say that they are sedimentary. You are allowed to write limestone or chalk because they are types of sedimentary rocks. But if you wrote anything about metamorphic or igneous rocks, you don't get the mark for that. But is that what people did? What did the examiners say? They said it was poorly answered on the whole. They were able to score just 1 mark for the correct reference to sedimentary rocks. Common errors and misconceptions include: many candidates simply described the formation of sedimentary rocks, failing to link the formation of sedimentary rocks with the absorption of carbon dioxide by marine organisms and its subsequent use in the formation of shells. Many incorrect responses referred to carbon dioxide combining with calcium to form calcium carbonate, or discussed carbon dioxide forming layers within the sediments, as if carbon dioxide was a solid material once dissolved in seawater. So there you go. So carbon dioxide is a gas that dissolves in seawater, but that doesn't make rocks. The sea creatures absorb the carbon dioxide gas, they turn it into solid calcium carbonate, and when those sea creatures die, they eventually become sedimentary rocks. Right, question 1b, part 2. Multiple choice, 1 mark. Complete the sentence by putting a cross in the box next to your answer. The substances formed in these rocks is A. Calcium carbonate, B. Sodium chloride, C. Calcium hydroxide, or D. Iron oxide. Right, the answer is A. Calcium carbonate. So there you go. And the other answer is not because there because you can't get them carbon dioxide. There's no examiner's notes to that, which makes sense because it's a multiple choice. Question 1c is 2 marks. If you see, I'm telling you how many marks each question is worth because the number of marks gives you an idea of how many points you need to write. So you need to write at least 1 point per mark. Iron seeding is the introduction of iron into the ocean. This stimulates the growth of small plants. Explain how the growth of these plants affects the amount of carbon dioxide in the atmosphere. Off you go. Right, the mark scheme says an explanation linking plants photosynthesize, so 1 mark for saying that plants photosynthesize, and then a 2nd mark for saying that therefore reduces or decreases the carbon dioxide levels. You are allowed to say plants take in carbon dioxide and release oxygen. You ignore respiration or breathing because that's got nothing to do with it. And you need to say that it lowers. Do people get that right? It was generally very well answered, with many candidates giving correct explanations linking photosynthesis with lowering carbon dioxide levels. Common errors. While many responses correctly referred to the correct process, namely photosynthesis, they often fail to mention to link this with the effect on the level of carbon dioxide in the atmosphere. Consequently, the 2nd marking point was not scored in many cases. In a few cases, the processes of photosynthesis and respiration were confused with each other. Well, yes, I can see why. It's the same equation, it's just opposite ends. So respiration is glucose plus oxygen makes carbon dioxide and water, and photosynthesis is carbon dioxide plus water makes glucose and oxygen. Right, question 1d is 2 marks. Carbon dioxide is one of the products of the complete combustion of methane in air. Write the word equation for this reaction. Off you go. Right, so the word equation is methane plus oxygen, arrow, carbon dioxide plus water. You get 1 mark for the left-hand side and 1 mark for the right-hand side. You ignore air. You're allowed to write water vapour because that's just the same chemical but in vapour form. But air is not oxygen. Air is a mixture that contains oxygen, and you wouldn't find air in an equation. Equations only contain elements or compounds, not mixtures. You ignore heats. because equations are about substances and heat is not a substance, that's just the energy. You are allowed to do the symbol equation, which is CH4 plus 2O2 arrow CO2 plus 2H2O, and you ignore state symbols in this case. Is there a yes, there are examiner's notes. It says the question was very well answered on the whole. Most candidates were able to score the 2 marks available for correctly writing the equation for the combustion of methane. This is a commonly asked question in the specification. Many candidates wrote a balanced equation for the correct formulae and scored full marks. However, occasionally a few who used a simple equation lost marks for incorrect balancing. So it's probably best to do the word equation. Common errors and misconceptions. In some of the responses, examiners noted that the terms hydrocarbon or simply fuel were given instead of methane, and air was given as an incorrect alternative for oxygen. Consequently, the reactants mark was not scored. In many incorrect responses, despite having been given one of the products, carbon dioxide, in the question, examiners noticed that the candidates were unable to recall either one or both products. Commonly given incorrect products included methane oxide, hydrogen. Consequently, the products mark was not scored. There you go. That's how you those are the mistakes you need to avoid for writing the equation of the complete combustion of methane with oxygen. Right, question 2 is about acids and electrolysis. So question 2a is a multiple choice. Acids can undergo neutralization to form salts. Complete the sentence by putting a cross in the box next to your answer. An acid reacts with a metal oxide to form A, a salt and carbon dioxide, B, a salt and hydrogen, C, a salt and oxygen, D, a salt and water. And the answer is D, salt and water. I expect there's not any, no, there's no examiner's notes about multiple choices. Acids also react with metal carbonates. The equation for the reaction of calcium carbonate with dilute hydrochloric acid is CaCO3, S, plus 2HCl, Aq, arrow CaCl2, Aq, plus H2O, L, plus CO2, G. Describe what you would see when solid calcium carbonate reacts with dilute hydrochloric acid. So it's 2 marks, and people get this wrong a lot. I will talk about what they get wrong in a second. I'm just finding the command words. Right, off you go. Right, so what would you describe? A description to include effervescence, fizzes and bubbles. And a second mark, the solid disappears or a colourless solution forms. Now, things that won't get you the mark, and I will explain why in a second, is carbon dioxide doesn't get you the mark, gas doesn't get you the mark, steam or smoke doesn't get you the mark. You can't say, well, we'll just go with that. So the reason why carbon dioxide doesn't get you the mark, well, first of all, I'll explain to you how this works. The reason you can use the equation to describe it is because of the state symbols. So at the beginning you have a solid and you're adding it to an aqueous solution. So that basically looks like water. Okay. So what you have at the beginning is a solid and something that looks like water. At the end you have an aqueous solution, a liquid and a gas. So you don't have a solid, which means that as the reaction happens, the solid has disappeared. You've also didn't start with a gas, but you ended with a gas. So as the reaction happened, a gas was formed. And the carbon dioxide is the gas. But if you wrote carbon dioxide, you still wouldn't get the mark. And the reason is the question is telling you to describe what you would see. So you don't see carbon dioxide, what you see is bubbles. You might know it's carbon dioxide because of the reaction, but you can't see carbon dioxide. It could be any gas that's colourless. So what you see is the bubbles. So the command word for describe says they ask you to link together a series of facts or pieces of information in a logical order. Some describe will ask you to give an account of a process of an experiment. Describe questions are often worth more than 1 mark. Make sure you include at least enough pieces of information to cover the number of marks available. So the examiner's mark said most candidates scored 1 mark only of the 2 available for the first few marking points, namely the correct observation fizzing or bubbling. Few candidates went further to mention disappears or dissolves to score the 2nd marking point. Common errors. Commonly seen responses for 1 mark were often gave fizzing and forming a white precipitate. Consequently, the 1st marking point was only scored. On many occasions, both fizzing and dissolving were correctly mentioned. However, an incorrect colour change was also stated, which negated the 2nd marking point. So that's a rule that stops people writing as many points as possible. If you wrote a correct point and then an incorrect point, you would lose the mark for the correct point. In some cases, but that doesn't count for ignore. So ignore means ignore it has no effect. But if you wrote something correct and incorrect, that would lose you the mark. In some cases, candidates did not read the question, which asked for what would be seen and simply named products. So there you go. That goes back to the describe. Question 2C. Hydrogen and oxygen are produced by the electrolysis of water acidified with a small amount of sulfuric acid. 2 marks. Explain what is meant by electrolysis. Let's just go back to these command words to find explain. Explain. You need to say how or why something happens. Answers to explain questions should link descriptions to reason behind what is happening. This means that because will be an important part of your answer. So there you go, have a go at it, and we'll give you the mark scheme in a sec. Okay, so the mark scheme. So an explanation to include for 1 mark, decomposing, breaking down is 1 mark, and for the 2nd mark, using direct current, DC supply, using electricity or electrical energy. Okay, so you can use splitting up or breaking up, but you can't use separate. So ignore separate, so separate won't lose you the mark. It says reject thermal, so if you wrote thermal you'd lose the mark, thermal decomposition, because that's different to electrolysis. Reject the breaking down of atoms, elements, bonds, because you're not breaking down atoms or bonds, you're breaking down ionic compounds. And for the electricity, you can't say alternating current, because you can't do electrolysis with alternating current. So 2CI, it was answered well on the whole. When only 1 mark was scored, it was for the 2nd marking point by reference to DC current or electricity. Common errors. Separating the compound was a phrase that was used which didn't get the mark rather than decomposing. In several cases, candidates simply discussed the uses of electrolysis and extraction of metals. So once again, that's a case of candidates not reading the correct command word. So this was explain what is meant by electrolysis, and they were describing electrolysis reactions. Right, question 2C, part 2. Describe the test to show that a gas is oxygen. 2 marks, go. And so you got to say a glowing splint for 1 mark and relights for another mark. And there's certain words you could use instead of glowing, like smouldering, embering. You can't say unlit, you can't say other tests, you can't say blown out. Or if you said a lit splint burns brighter, that's 2 marks, because oxygen makes things burn brighter. Examiner's notes, it was answered very well. Occasionally both marks were lost by candidates not correctly referring to the use of a glowing splint. Alternatively, burned out or blown out splint was seen, which is incorrect. Occasionally candidates confused the test for oxygen with that for hydrogen, naming the use of a lighted splint and a squeaky pop, or for the test of other gases such as chlorine or carbon dioxide. So just need to remember your test for gases. Right, question 2C part 3, describe a test for hydrogen, 2 marks. Well, yes, we've just done that, but off you go anyway. Right, so the test for hydrogen is a lit splint for 1 mark, burns with a squeaky pop. You can either say the gas burns or there's a squeaky pop, either one. It was answered very well. Occasionally candidates confuse the test for oxygen and hydrogen, and occasionally candidates referred to a squeaky pop test, which is not a correct test. So you need to describe what you see. So the squeaky pop test, saying squeaky pop test is not a description. You need to say what you would see. Right, question 3 is on organic compounds. Methane, CH4, is a hydrocarbon. Chloro-difluoromethane can be formed from methane. A diagram of one molecule of this compound is, so the carbon in the middle, and it's bonded to 1 chlorine, 2 fluorines and a hydrogen. Explain whether or not this molecule is a hydrocarbon. 2 marks. Right, so the answer is no, because the definition of because a hydrocarbon contains carbon and hydrogen only, so it's 1 mark for the only and 1 mark for saying what a hydrocarbon is, or no, because this molecule contains chlorine or fluorine and other elements for 1 mark, as well as carbon and hydrogen for the 2nd mark. Okay, so did people do all right in that? It was very well answered. Occasionally marks were lost by candidates using inappropriate terms such as carbon and hydrogen molecules, or referring to fluoride and chloride. Yes, so fluoride, you'd only find fluorine being called fluoride in an ionic compound like calcium fluoride. Okay, that's the only time you use ides for halogens. A few candidates correctly identified that it is not a hydrocarbon, but cited the wrong reason, such as it doesn't have double bonds. Very few candidates incorrectly claimed that the compound was a hydrocarbon by reference to the fact that it contained hydrogen and carbon. So they missed the other bit. It has to contain hydrogen and carbon only and nothing else to make it a hydrocarbon. Right, question 3a, part 2. Chloro-difluoromethane is a gas. When it is bubbled through bromine water, the orange colour remains. State what this shows about the structure of this compound. 1 mark, go. Well, it is saturated or has no double bonds. Okay, or you can say it only has single bonds. It was well answered on the whole. Either saturated. Incorrect response is simply said alkane rather than saturated. Well, it's not an alkane because alkanes only have carbon and hydrogen. Saturated means all single bonds. All alkanes are saturated, but they only contain carbon or hydrogen. So that's why it doesn't count when you say alkane. You've got to say that it contains only single bonds, not just single bonds, because even alkenes have single bonds. It's just they have 1 double bond. Some candidates got the reasoning the wrong way around and said it was unsaturated, and some people said no spare bonds, which is incorrect. You're supposed to say no double bonds. Gases in the atmosphere, right, this is question 3b. Gases in the atmosphere that trap heat from the sun are known as greenhouse gases. Give one possible consequence of an increase in the amount of these gases in the atmosphere. 1 mark. So the consequence is Earth's temperature may rise, increase. Reject references to ozone layer. Yes, people always confuse greenhouse gases in the ozone layer. Ignore pollution. You're allowed global warming and climate change. You're allowed melting of ice, sea levels. Allow alterations in areas for crops. Allow extreme weather conditions. So if you know about global warming, you should be fine. It was very well answered. Commonly incorrect responses refer to burning fossil fuels. And fewer people are referring to holes in the ozone layer, which is good. CFCs cause holes in the ozone layer, chlorofluorocarbons, not greenhouse gases. Right, question 3b part 2. Complete the sentence by putting a cross in the box next to your answer. Chloro-difluoromethane is a gas that traps heat from the sun. Another gas that traps heat from the sun is A. Argon, B. Nitrogen, C. Oxygen, D. Water vapour. And the answer is D. Water vapour. Right, question 3c, it's another equation. When chlorodifluoromethane, CHClF2, is strongly heated, it decomposes to form tetrafluoromethane, C2F4, and hydrogen chloride. Complete the balanced equation for this reaction. So you have 2 CHClF2, and you have 2 products. So it's 2 marks, off you go. So the products are C2F4 plus 2HCl. You get 1 mark for the correct formulae and 1 mark for the correct balancing. 3C. So that wasn't, that was, it was generally well answered. The common misconceptions. In several responses, candidates only wrote the correct formula without balancing. That's 1 mark. Examiners noted that many candidates lost marks due to careless writing formulas such as HCl with a capital L or HCl with a lowercase c rather than HCl with a capital H, capital C, lowercase l. A common error in responses which did not score was H2Cl2 rather than HCl, 2HCl. So you've got to know the difference between big numbers and little numbers. If you have a big number in front of something, it's two separate things that aren't joined. So H2Cl2 would be 2 hydrogens and 2 chlorines all joined together. But 2HCl is 1 hydrogen and 1 chlorine joined together, and then another molecule made of 1 hydrogen and 1 chlorine together. Okay, question D. The structure of a molecule of tetrafluoromethane is this. So it's a carbon-carbon double bond and 4 fluorines. A sample of this gas was kept in the cylinder under high pressure. When the cylinder was opened, no gas remained. Instead, it contained a slippery, waxy, white solid. State the type of reaction that occurred when tetrafluoromethane gas formed the solid. That's 1 mark. Off you go. Right, it's a polymerization reaction. The majority of candidates did not score. Very few responses. Many responses incorrect refer to precipitation, electrolysis or oxidation. So yeah, it is quite hard to think about. So the clues in the question were there's only tetrafluoromethane in there, so it doesn't react with, there's nothing else in the cylinder. So there's no oxygen, so it can't burn. There's, what else did it refer to? There's no electrolysis going on because it's kept in a pressurized container. The other clue is it's got a carbon-carbon double bond. So that's carbon-carbon double bonds. You need one of those for the molecule to form polymers. It's under high pressure. You need to form high pressure to form polymers because the high pressure forces the molecules to bond together. Deduce the name of the solid formed. Off you go. The solid formed is polytetrafluoroethene, or PTFE, or Teflon. So there you go, polytetrafluoroethene. You can't say polytetrafluoroethane. So how many people got that? A significant candidate did not score the marks for naming the solid. This was a little surprising, given the fact that the name of the monomer, the more difficult part, was provided in the stem of the question. Of the correct responses seen, many candidates were either able to score Teflon or PTFE. Pleasingly, of those candidates who gave the chemical name of the polymer, most managed to spell it correctly. The most common incorrect answer was wax, precipitate, white solid and plastic. Well, that's because it was called waxy. So naming polymers is actually quite straightforward. You take the name of the monomer, as in the small molecule it's made from, which is given to you, as the question said, tetrafluoroethene, and you just stick the word poly in front of it. And that is a technically correct answer, okay? I know polymers have, trademark names like Teflon. So this substance is called Teflon in the shops, but it's the name for the compound is called polytetrafluoroethene. And in this case, you can say PTFE, which is short for polytetrafluoroethene. Yeah. But if you were given a molecule that you've never seen before and told it's a monomer, but you were told its name, to work out the name of its polymer, you just stick the word poly in front of it. Okay, I'm going to stop the video here. So we're just hitting half an hour, so that's plenty of time. That's more than enough time for one video. So I'm going to stop here and do the rest of the paper another time on another video. So yes, good luck. Thank you very much.